In this lecture, we are going to discuss the solution or proof of two important relations of numerical analysis relating to the difference operator. And we are going to prove the first relation first and one by one. Right? We start the first relation from left hand side, and we already write here the left hand side of the first relation. Okay, and clearly this is u0 plus u1x by factorial 1, u2x square by factorial 2, and so on. And this can be written as u0 plus, we write u1 as eu0, okay, into x by 1 factorial, and this can be written as e square into u0 into x square by 2 factorial, and so on. And taking u0 from the right, common right, we get this is 1 plus, this is xe by 1 factorial plus x square is square by 2 factorial, and so on, into u0. Okay, and clearly this is the series of e to the power x. So we get the series e to the power x e into u0. Right? And what is e? E means 1 plus delta. We know this relation, and putting the value of e as e to the power x into 1 plus delta of u0, that is e to the power x into e to the power x delta of u0, and we expand again this e to the power x delta by the exponential series, and this gives, this is 1 or I, we can write, plus x delta plus x square delta square by factorial 2, and so on to u0, and operating u0 we get e to the power x into u0 plus x delta u0 plus x square by factorial 2 into delta square u0 plus, and so on. Okay, and clearly in the right side this relation is here, so we get the right hand side, and we can write it as in the right side, this is e to the power x into, in the third bracket, u0 plus x delta u0 by 1 factorial plus x square delta square u0 by 2 factorial, and so on. And this is the right side of 1. Okay, so we prove of 1. Right, now we go to the proof of 2. Prove the second relation, we also start from the left side, and we already write here the left side of 2. And using the shift operator, the left side can be written as u0 minus, this is e u0, this is e square u0, and so on. And now taking common u0 from the right, and we get, this is I minus e plus e square minus 2, so on. And clearly this is the series of 1 plus e whole to the power minus 1 into u0. Now we get the relation of e and delta. This is equal to e equal to I plus delta or 1 plus delta. So this is 1 plus 1 plus delta to the power minus 1 into u0. And this is 2 plus delta to the power minus 1 into u0. And we take common 2 from this, we get outside is half, and this is 1 plus delta by 2 whole to the power minus 1 u0. Now we write the expansion of this series, and the series becomes half into 1 minus delta by 2 plus delta square by 4 minus delta q by, this is 8, and plus so on into u0. Okay, and by multiplying half we get the result as half into u0 minus delta by 4 into u0 plus delta square by 8 into u0, and this term is delta to the power q by 16 into u0, and so on. Okay, and clearly this is the right hand side. Okay, and these two relation here we take from your previous year university paper of numerical analysis. Okay, this is very simple proof but interesting proof of numerical analysis. Thank you for watching.